The universe has been expanding since the Big Bang 13.8 billion years ago, and it's getting faster in its acceleration as it expands. This rate of expansion is known as the Hubble Constant, and astronomers have spent years trying to quantify its speed. Now, in the most precise measurement ever made, experts have found the expansion is about 8% faster than predicted. This number does not fit in with measurements of the radiation left over from the Big Bang. This means if the measurement is backed up by further study, it could lead to all the laws of cosmology being completely rewritten. I think that there is something in the standard cosmological model that we don't understand, Professor Adam Rees, a physicist at Johns Hopkins University, who led the latest study, told Nature. The accepted model of cosmology says the competing forces of dark matter and dark energy have driven the evolution of the universe. Dark matter's gravity slows cosmic expansion, while dark energy pushes in the opposite direction and causes it to accelerate. If the universe is expanding faster, it could mean dark energy, the unknown force that is thought to be responsible for the observed acceleration of the expansion of the universe, has become stronger since the beginning of time. Previous studies by Professor Rees and others had indicated that dark energy's strength has been constant. For years, those predictions have disagreed with direct measurements of the rate of cosmic expansion, known as the Hubble Constant. The Hubble Constant is calculated by observing how quickly galaxies in the relatively nearby universe move away from the Milky Way, using stars of known brightness called standard candles. But the measurements had been within a certain error margin, meaning the differences could be ignored, until now. Professor Rees's team studied two types of standard candles in 18 galaxies using hundreds of hours of observing time on the Hubble Space Telescope. They measured the constant with an uncertainty of 2.4%, down from the previous best result of 3.3%. They found the speed of expansion to be about 8% faster than that predicted based on Planck data. Professor Kevork Abazagian, a cosmologist at the University of California, Irvine, who was not involved in the study, said the results have the potential of becoming transformational in cosmology. If we take the conflict between Planck high redshift measurements and our local determination of the Hubble constant at face value, one plausible explanation could involve an additional source of dark radiation in the early universe, the researchers said. One possibility is that the elementary particles that make up dark matter have different properties to what is currently thought, which would affect the evolution of the early universe. Another option is that dark energy is not constant but has become stronger in recent years. Planck researcher Professor François Bouchet of the Institute of Astrophysics in Paris says he doubts that the problem is in his team's measurement, but that the new findings are exciting regardless of what the solution turns out to be. A third possibility is that standard candles themselves that are not reliable when it comes to precision measurements, said Professor Wendy Friedman, an astronomer at the University of Chicago. She and her team are coming up with an alternative method based on a different kind of stars,